Okay, so today we're going to finish up 3.3, or I should say start 3.3, quadratic functions and their properties. Hopefully you guys have seen all of this before, so it's a little bit of a refresher. Like I said, most of chapter 2 and 3 should be a little refresher. Few things here and there you haven't seen, but then chapter 4 is when we start doing quite a bit of new stuff. And then definitely when we get into trig, that should all be new for many of you. So I want to talk about quadratic functions. A quadratic function is a function of the form ax squared plus bx plus c equals 0, where a, b, and c are elements of the reals. By the way, this is just a little symbol that means element or part of. So an element of the reals, and a cannot be 0. The domain is negative infinity to positive infinity, or all real numbers. Okay, so there's a little bit of information we need to know. Okay, so the first thing we need to know is if a is greater than 0, the graph of the, and remember, quadratics are also referred to as parabolas, so the graph of the quadratic opens up. And remember, greater than 0 is a fancy way of saying positive. So if a is greater than 0, meaning the number in front of the x squared term, the graph will open upward or be concave up, okay? If a is less than 0, the graph of the quadratic opens down. Okay, that's pretty simple. The lowest point of a parabola is called, the lowest or highest point of a parabola is called the vertex. Okay. The vertical line passing through the vertex of a parabola is called the axis of symmetry. Okay. And it's called the axis of symmetry because you could literally fold the parabola right over that axis and it would land right on itself. So it creates the symmetry, or it gives you a way to think about the symmetry of a parabola. Okay. So we have two main ways for graphing a parabola, and are basically two main ways for graphing a parabola. The third way would be cheating and use your calculator. I mean, it's not really cheating because all of you are supposed to have a calculator for this course, but I still want you to know how to do it using work and then also on the calculator. Okay, so option 1 for graphing, complete the square. So completing the square. So if given ax squared plus bx plus c equals 0, equals f of x. You know what, I should maybe say it's worth f of x over here, not equal to 0. Yeah, it eventually, we set it equal to 0, but I should change that to f of x up top. So yeah, please go and fix this. Makes this f of x not equal to 0. Okay, so if given ax squared plus bx plus c equals f of x, and you need vertex form, which is a times x, which is f of x equals a times x minus h quantity squared plus k, use completing the square. Now, I'm going to be honest with you guys, completing the square for me is one of my least favorite ways to do math. I can do it and it's no big deal, but I would prefer other techniques. So this is just one option. If they don't specifically ask you to complete the square or put it in vertex form, I probably would use another technique, what I'm going to show you in option 2. Okay, so this has a vertex of h comma k and an axis of symmetry, which is x equals h. Okay, it's just the vertical line x equals h. So whatever the x coordinate is for our vertex, that's how you can also draw the axis of symmetry. So let me show you what I mean. Okay, so suppose we're given, so it says graph using vertex form for f of x equals negative 2x squared plus 6x plus 2, okay? And this is kind of like our standard quadratic form, okay? And we want to put it in this form because this form is the easiest way to graph, okay? So what we're going to do is we're going to follow some rules for completing the square. So completing the square. All right, I shouldn't say rules. It's more of a guideline. Okay, so for completing the square, first thing you do is a must equal 1. So if it doesn't, you have to fix that. So in our particular problem, a does not equal 1. So I have to divide everything by negative 2, by negative 2, by negative 2. But I also even divide f of x by negative 2 because whatever you do to one side, you have to do to the other, okay? So now I have negative f of x over 2 equals x squared minus 3x minus 1, okay? Now, step 2, take b and divide it by 2 and then square it, okay? So now what we're going to do is we're going to do a little scratch work over here. We're going to take b, which is negative 3, we're going to divide it by 2, and then we're going to square it. So this will become positive. This will become positive 9 over 4, right? Because 3/2 times 3/2 is 9 over 4. So what you do then is you come over here and you say negative f of x over 2 equals x squared minus 3x, and then you do plus blank. And that's right where you put 9 over 4 minus 1, okay? Now you have a couple choices. There's a bunch of ways that you can do this. You know how you just added 9/4 right here? You could subtract off 9/4, right? Or let me do it in green. That would work, okay? Or you could add 9/4 to the other side, but then you're gonna eventually subtract it back. So basically, if you add 9/4 and subtract 9/4, how much did you just add to the right-hand side of the equation? Right, 0, you added nothing. And whenever you add 0 to something, does it do anything? So if you have $5 and I add 0 to it, that does nothing. So what we're gonna do here is we're going to add 9/4 and then subtract 9/4 to make sure that we didn't change the problem, okay? So now let's rewrite negative f of x over 2 equals, now this should be factorable now. And then 9/4 negative and 1 negative, that's what, negative 13 over 4, right? So now this factors to x and x. Now here's where you might kind of say that this is really hard. How do you factor fractions? Well, you don't even have to stress about it because whatever you had in here before you squared it, that's actually what goes right there and there. So now this is already factored for me. And again, why should it be so nice? Because we're the ones that are completing the square, right? We're the ones that are making this happen. So this fits the pattern that we designed. So x minus 3/2 quantity squared plus 13, oops, I think that's wrong. That's a minus. I had too many minuses, sorry about that, guys. 13 over 4. Now here's the thing. Our job is to have plain old f of x equals, and we want vertex form. So if we come up here, do you guys see vertex form? right? Do you see anything attached to the f of x, or is it f of x all by itself? Right, it's f of x all by itself, so we got to come over here, and we got to cancel that -2. So we're going to multiply by -2 over 1. We're going to multiply by -2 over 1. We're going to multiply by -2 over 1. Multiply every piece of the equation by -2. So then this will cancel with this, and we'll just be left with f of x. And now this will become -2 times x minus 3/2 quantity squared. And then that will cancel, and that will become 2. So this will become plus 13 over 2. Okay? And 13 over 2 is what, 6.5, 6.5? So now, when we go to graph, okay, it's not ideal. This wasn't maybe the best problem to pick first. So let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, so on and so on. So we know that A is equal to -2, which is less than 0. So we know we're downward facing. We know that our axis of symmetry and our vertex are like intertwined. So first, let's find our vertex. Well, our vertex, according to this, is always h comma k. So the opposite of whatever's in here. So this is a -3/2. So we're going to take 3/2 positive. And what's my y coordinate? 13/2. Now, if you guys don't like that, then do 1.5 comma 6.5. I don't mind decimals as long as they're not rounded off. These are not rounded off decimals. These are exact. So I can graph with these a little better. And then my axis of symmetry would be x equals 1.5. So let's go and graph our parabola now. I'm going to go over 1.5, and I'm going to go up 6.5. I'm going to put a point right there. That's 1.5, 1.5 comma 6.5. Right? And now we're going to go downward. I don't have a bunch of other points, so I'm just going to kind of sketch it. I don't know exactly. Oh, actually, we know that it has a -2 in front, so that means it's narrow. We learned that in one of the previous sections. So we know it's going to be kind of narrow, right? By a factor of -2 or by a factor of 2. So we're not exactly sure, but we know it's going to be narrower than a regular parabola. Okay, so this is just a rough sketch. We use completing the square to find the vertex. Okay. Okay, so let me give you guys one so you can pause the video and give it a shot yourself. Okay. Oh, geez, these are all terrible. Every one that I find, you guys, is really, really bad. Let's try this one. Okay, this one's bad, but not horrible. So f of x equals 2x squared minus 4x plus 1. Okay, so we want to put it in graph using, they'll say transformations, but what that really means is put it in vertex form, graph using transformations, and find the vertex and axis of symmetry. Okay. So take a minute, pause the video, and see if you can complete the square on this problem and put it in vertex form. All right. Okay, so hopefully you guys unpause the video, and the very first thing you hopefully did was divide by 2, divide by 2, divide by 2, divide by 2, right? Remember, you always need a 1 in front. There's other ways to do this, but this is just how I was taught. So I'm just going to do f of x over 2 equals x squared minus 2x plus blank plus 1/2, right? So now I have to do my completing the square scratch work over here. I'm going to take -2 and I'm going to divide it by 2, and then I'm going to square it. So this will become -1 squared, which is 1, okay? So I put a plus 1 right here, all right? But then I have to put a -1 here to counteract the fact that I just added 1 to the right-hand side of the equation. If I subtract that 1 right back off, this one and this one amount to 0. So I did nothing. Okay, so now we're going to kind of set this up. It should go a little bit smoother. I know that this is going to be factorable. Remember, whatever was in here before you squared it is what are the factors. And then 1/2 minus 1 would be minus 1/2. Now, this time, hopefully it'll be a little bit nicer. When I multiply by 2 over 1, 2 over 1 to everything, these 2's cancel. I'm left with f of x equals 2 times x minus 1 squared minus 1. So this one is a lot better. We have a vertex of 1 comma negative 1, and we have an axis of symmetry of x equals 1. Oh, I didn't do the axis of symmetry on this graph, huh? Well, the axis of symmetry would have been this. Sorry about that. It's this line right through the vertex. And it's not even part of the graph. It's just like a line that you visualize going right through. So now I should be able to graph this pretty well. So we're going to go, let me see, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so our vertex is 1, negative 1. So that's right there. And we know that it opens upward, but it's a little bit narrow. So I'm just going to make it like this a little bit. That's actually not narrow enough, I don't think. So you might be asking yourself, oh, and then we need our axis of symmetry right there, okay? So you might be asking yourself, you know, these are rough sketches, but they're not very accurate because we need more points. So that's what the second half of this section is we can use intercepts. Instead of just these little rough sketches using vertex form, we can also use intercepts and other values. So now, option 2 is graphing quadratics from properties. So instead of using vertex form, we're going to kind of memorize a few techniques. So if f of x is equal to ax squared plus bx plus c, okay, and a obviously can't equal 0 because if a were 0, this would just be a line. It wouldn't be a quadratic. Okay, the vertex can be found. The vertex can be found much more simplistically. It can be found very quickly by doing negative b over 2a comma f of negative b over 2a. So don't panic too much. Negative b over 2a literally means you take this b and you divide it by 2 times that a, whatever that number is. And then whatever you get for that number, let's say you do 4 divided by 2 and you get a 2, you then plug it in and it'll give you the y coordinate and you have your vertex. No completing the square, none of that. So this is much better than that. So let's look at a problem. F of x equals 3x squared plus 12x minus 5, okay? Okay, so remember how in completing the square we had to divide by 3? We don't have to do any of that if we're just trying to use properties, okay? So all I'm gonna do is I'm gonna say negative b. So what's my a, what's my b, what's my c? So my a is 3, my b is 12, and my c is negative 5, all right? So now if I want the vertex, I just need to find negative b over 2a. So in this case, that would be negative 12 over 2 times 3, which would be negative 2, right? And then f of negative b over 2a is just f of negative 2. Whatever you got from that previous problem, you plug it into the function. So this would be 3 times negative 2 squared plus 12 times negative 2 minus 5. So this would become 12 minus 24 minus 5. So this would be negative 29, that'd be negative 17, I believe, okay? Now we need a little bit more information because even though we have the vertex, we now know that our vertex is negative 2 comma negative 17. We know it opens upward right? So we know it opens upward because A is a positive number. And we know that it is vertically stretched, right? Since absolute value of 3 is greater than 1, right? Remember from the previous sections, the absolute value of A is greater than 1 means that it's stretched, and the absolute value of A less than 1 means it's vertically compressed, vertically stretched or compressed, okay? So we have our vertex, we have our axis of symmetry. I mean, look at all the information we have. X equals -2, but I want more. I want to have a little bit better graph. So I want to find x-intercepts, and I want to find y-intercepts. So remember I told you guys, if you ever need to find x and y-intercepts, all you need to do is let x equal 0 for y-intercepts and let y equal 0 for x-intercepts. So for the y-intercepts, I'm just going to find this real quick. There'll only be one. So I have 3x squared plus 12x. I'm right here. 3x squared plus 12x minus 5, and that's going to equal 0 now because I'm going to let y equal 0. Oops, no, I'm sorry. For the y-intercepts, I'm going to say that y equals 3 times 0 squared plus 12 times 0 minus 5, right? And you'll see in the long run, it'll always, the y-intercept will always end up being the c, the number that's off by itself, because this guy will cancel and that guy will cancel, okay? So my y-intercept is actually y equals -5. So then I have the point 0, -5. This is where it crosses the y-axis. The x-intercepts, I have 0 equals 3x squared plus 12x minus 5. Okay, so all I have to do now is I have to factor. Okay, let's see. This does not look very factorable. Let's see here. So we have 0 equals 3x. This is x. Yeah, this isn't going to be factorable, you guys. So this cannot be factored. So that means that either the answers are really, really ugly or there's something weird going on. So I'm going to do something called the determinant, and the discriminant. And it says that b squared minus 4ac. If this is greater than 0, then we have distinct x-intercepts. If b squared minus 4ac is less than 0, then we have no okay. And then if b squared minus 4ac equals 0, we have one x-intercept. It bounces off the x-axis. Okay, so let's see what this one is, because I already know this one isn't factorable. So let me see what b squared minus 4ac, this is called the discriminant. The discriminant. So b squared, so it'd be 144 minus 4 times 3 times -5. So that would be, let me see, 60, I believe it's 84, but let's just double check. 144 minus 4 times 3 times -5. Wait. Oh no, we add 60. So it's 204. And it's positive. So there is, in fact, x-intercepts, okay? But the problem is the x-intercepts are not clean. They're ugly, irrational numbers, okay? So I'm going to take out my calculator. I'm going to try to graph this guy. I'm going to do 3x squared plus 12x minus 5. And I'm going to graph this. And I get not very nice x-intercepts. So we're going to have irrational x-intercepts. So for now, what I'm going to do is I'm going to approximate them. And then later on in chapter 4, I'll show you how to find them exactly. Okay. So we're going to say that we have, let's see here, we're going to go over -2, -17. So I'm going to say this is -1, -2, and I'm going to say -17 is like down here somewhere. Okay, you guys? And then when I look at my parabola, it crosses here. Crosses like right about there. 1, 2, 4.5-ish. So it looks like it crosses right here. Okay, so that is what my parabola would look like. And again, I'll fill you guys in on how to find the x-intercepts more cleanly. This particular one had irrational, where we just had to use the discriminant just to see. I was kind of hoping when we did it that we would end up with you know, a negative number or something, so I could not have to worry about the x-intercepts right now. Let me see here. This one. No. Let's try this one. Let's try another one. So let's have one that ends a little bit nicer, okay? Oh, by the way, just to remind you, the vertex was -2, -17. The axis of symmetry. I don't always draw the axis of symmetry. Your book will almost always ask for it, but I figure if you found the vertex, you can find the axis of symmetry. Oh, I forgot to use the y-intercept of -5. So 1, 2, 3, 4, 5, right there somewhere. It's a bad drawing. It's not really to scale. I'll have to clean that up a little bit. I was just frustrated that we couldn't get the nice numbers. I must have wrote it down wrong in my notes. Okay, so let's look at this one. So suppose we have f of x equals -x² plus 4, no, that's the wrong one. Oh, here we go. -x² plus 4x plus 5, okay? So what I'm gonna do is I'm gonna try to graph this one once again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we kind of got it. And remember, I'm not going to use completing the square this time, but what I want is I want the vertex. I want the axis of symmetry. I want the axis of symmetry. I want the y-intercept. I want the x-intercepts, if there are any, or an approximation if we can't find it by factoring. I want the, what's one other thing I wanted? Domain. I want the range. I want concavity, meaning is it open upward or is it open downward? Is it stretched vertically or compressed or neither? And then last but not least, does it have a maximum value, or what is the maximum value or min value? Okay, so this is a lot of information that we can get from this parabola. So first thing we need to do is -b over 2a. So this would be -4 over 2 times a, which is -2. So we should get -4 over -2, which is 2. Then I'm going to do f of 2, and that would be -4 plus 8 plus 5, and that would be 9. So then our vertex is 2, 9, right? Okay, so we have a vertex of 2, 9. That means our axis of symmetry is x equals 2, -b over 2 times a. Yep, that's good. Okay, now we want to find our y-intercept. We know the y-intercept is just that, so it's going to be 0, 5. But the x-intercepts require a little bit of work. So we're going to do 0 equals -x² plus 4x plus 5. I'm going to factor out the 0, or factor out the negative. And then I'm going to divide both sides by -1. So we have 0 equals x² minus 4x minus 5. Now this should be factorable this time. X minus 5, x plus 1. So x minus 5 has an x-intercept of 5, and this has an x-intercept of -1. Okay, so we now know that this is 5, 0, and we know that it's -1, 0. Those are my x-intercepts. The domain, remember what we talked about parabolas. Look at this parabola. How far left and how far right is this parabola going to go? Well, it's going to open up forever in both directions, right? So the domain of all vertical parabolas is negative infinity to positive infinity. So that's a gimme question. Now the range, we're gonna have to graph it first, okay? Because A is negative, we know that this is concave down, since A is less than, oops, since -1 is less than 0, right? Our A is -1. We know that it is neither stretched nor compressed, neither, since the absolute value of -1 equals 1, instead of less than 1 or greater than 1. And max value, we need a little help on that still, okay? So let's see here. 2, 9, so I'm gonna go over 2, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's unfortunate. But we know that the y-intercept is 0, 5, so 1, 2, oops, 3, 4, 5. We know that. We know the x-intercept is -1, 0, and we know this one, 1, 2, 3, 4, 5, 0. So this is a much better drawing now. We're a little bit more confident of what our drawing is going to look like this time. Oops. Okay. Well, it was a much better drawing until I screwed it up. Okay. Okay, so that's our parabola. We know that we have our axis of symmetry right here, right? That's our axis of symmetry. And then does this have a highest point or does it have a lowest point? So remember I talked to you guys about in order for it to be a maximum or a minimum, you have to be able to touch it. These are going on forever, so you can't actually touch these values. So then what we have is we have no absolute minimum, but we do have a maximum. So we have a maximum right here. That's our vertex. Our vertex is actually our maximum. So you say that you have a maximum value of y, or let me put it this way, max value, and they normally want the y value. So max value of 9. Right? So they normally just want the maximum height. Now the range is going to be the lowest point to the highest point. Well, we know that this guy is going to be all the way down here, right? It's coming from negative infinity down here, and it's going to rise all the way up to here, the vertex, which the vertex in this problem is 2, 9, right? That's the vertex right there. So the highest value it'll ever make it to is 9, and it will actually touch 9, so I'm going to use a bracket. Okay. So that is a lot of information about parabolas. Some of it you know, some of it you're learning. We're going to practice more of this. Parabolas are going to come up throughout the semester. So we'll have more time to work on this. But I prefer option 2, right? So option 2 uses properties. Okay, see how it says, oops. Option 2 says graphing quadratics from properties. I prefer the -b over 2a and f of -b over 2a. But if they ask you to use transformations, that's a code word for saying, hey, put it in vertex form. So that means you have to complete the square. All right, you guys, that's it for this video. I'm going to go ahead and post this one for you guys to watch, and I will see you in the next class.